In the last video, we talked about how we actually can create confidence intervals for our paired differences when we're comparing two population means when we cannot assume independence. So to do that, we're actually going to need to create our d sub I values. So we're going to create a new row here. We're going to call it d sub I. And we're going to just do the differences for our x1 minus our x2. So 124 minus 123 is a 1. 128 minus 125 is a 3. 120 minus 118 is 2. 1, 2, 2, and a 3. And if we continue our bar values here, so we're going to get our d bar value. So this is now d bar. And we're going to say d bar is equal to the average of those. So this will actually be the same average as if we did it the other way for our confidence interval. It's just going to be the 2. So if we average all these values, we're going to get 2. If we find the s sub d value, so s sub d, for the standard deviation for these, we get 0.8165. And if we look at the n sub d, so the number of differences that we have, we still have that same 7 that we had for all the other ones. So now we're just going to use this information to create our confidence interval. But first we're going to need to set our alpha level. So we're going to say alpha is equal to our same 0.05 that we used in the past, which is going to turn our t sub alpha over 2 with n sub d degrees of freedom, or n sub d minus 1, excuse me, which is going to turn into our t of 0.025, comma 6, which is going to be equal to 2.447. Now we're just going to plug all these values into our confidence interval formula. So our formula was d bar plus or minus our t sub alpha over 2 times sd over the square root of nd. We plug in our values, we get this is equal to 2 plus or minus our t value of 2.447 times sd, which is 0.8165, over our square root of n, square root of 7. So we get that, we calculate that to be 2 plus or minus our 2.447 times 0.3086, which gives us a complete confidence interval of 2 plus or minus 0.7552. So we get a new confidence interval here, and if we look at this, we see that our confidence interval is not going to get anywhere near 0. So it'll be a different result than if we did for our original method, since our hypothesis has failed, saying that 0 was a possibility for the differences. And now we can see that that's not the case, since we're doing a paired differences because we cannot assume independence.